Okay, today we're going to learn about ellipses and hyperbolas that are not centered at the origin. And the formulas sort of look like a combination between the circle formulas and the ellipse and hyperbola formulas. On the horizontal ellipse, you notice instead of having an x squared at the top and a y squared at the top, we have an x minus h squared and a y minus k squared. And the a and the b, a squared and b squared, stay the same for a horizontal, and they stay the same for a vertical. So essentially the only thing that changes is the origin, is the center. The center is no longer the origin 0, 0. The center of the ellipse is now h, comma, k. And you have to remember to take the opposite of h and k just like you do in a circle. Same thing with the hyperbolas. In a horizontal hyperbola, the x squared comes first. In a vertical hyperbola, the y squared comes first. Okay? And in this case, a squared is always at the beginning. And same thing, instead of your center being 0, 0, your center is now hk. And again, having to remember that the h and the k, well, that got kind of dark, switch places on the vertical hyperbola. And then your asymptotes also slightly change up the formula for your asymptotes a little bit. It just takes into consideration the fact that the center is not 0, 0 anymore. Otherwise, all the formulas stay the same. So let's take a look at a couple of examples. We're going to look at this first example down here, and we're going to do a couple of things. We're going to tell if the conic is an ellipse or hyperbola, which we can tell right away. We're going to put it in its standard form. Then we're going to identify the foci, the center of the foci, and if it's a hyperbola, we'll also identify the asymptotes, and we'll also get a graph of the conic. So if I look at this first problem, I can actually tell right away that this is an ellipse. And the reason I know this is an ellipse is because there's a plus between the x squared and the y squared. If there's a minus between the x squared and the y squared, you're going to have a hyperbola. So just like we did with the circles, I'm going to group the x's together. So I'm going to group the 4x squared with the minus 8x. And then I'm going to leave a blank. Plus, then I'm going to group the y squared with the minus 2y. And I'm going to leave a blank. Equals negative 1. Okay. Now all I have to do is make sure that the numbers in front of my x squared and my y squared are both a 1. If you notice here, the number in front of the x squared is a 4. This is going to be slightly different than the way we did it before. Before we divided everything by 4. But in this case, I don't want to divide everything by 4 because I would also have to divide this y squared by 4, which then the number in front of my y squared wouldn't be a 1 anymore. So what I'm going to do with that 4 instead is factor it out. So I'm going to have 4 parentheses x squared minus 2x, and still leaving my blank. Don't have to factor anything out from the y's because the number in front of the y squared is already a 1. Equals negative 1. Now I'm ready to complete the square. So on the first one, I have to add a 1 because half of negative 2 is 1 and 1 squared is 1. But now here's where you have to be really careful. You have to picture redistributing this 4. If I redistributed that 4, that 1 is really not a 1. It's really a 4, 4 times 1. So you have to be careful. I didn't really change this side by 1. I changed it by 4. So I have to add a 4 to the other side. That's the only tricky part with these versus when we did the completing the square with the circles. Now for the y's, I also have to add a 1 to complete the square. And there's no number out front to multiply it by, so I simply add a 1 to the other side. Okay, now just like we do with the circles, we factor. So I have 4 x minus 1 squared plus y minus 1 squared equals 4. Okay, and last step, remember on all the ellipses and the hyperbolas, we want a 1 on the right side of the equation. So I want to go ahead and divide everything by 4. So what that would give me here, if I divided this side by 4, the 4 would simply cancel out. If I divide the y minus 1 squared by 4, that gives me a 4 in the denominator. And then my right side is 1. And if it helps you to think this through, you can put this side over 1. And there you are now in your ellipse, your standard formula for ellipse. So I can actually figure out what my center here. My center of this ellipse is HK. So remember, taking the opposite, that's H, and that's K. So my center is 1, 1. And just like we did on any ellipse, even the one centered at the origin, we identified A and B. Remember, on an ellipse, A squared is the bigger one. So this 4 is actually my A squared, and this 1 is actually my B squared. Okay, so this is actually a vertical ellipse. So A is 2 because A squared is 4, and B is 1. So now it pretty much works the same, except for now, instead of starting at 0, 0 as our center, we start at 1, 1 as our center. So I'm going over here to my graph, and I'm putting a point at 1, 1. This A is how far I go out on my y-axis. So from that center now not from the origin, this is our new center, I go up to 1, 2 to 3, and then I go down to 1, 2. And then the B tells me I go out from the center, so you always have to return back to your center, go out 1 unit either direction horizontally. And there you can see now I have my ellipse. So I'll go ahead and graph that. And it looks something like that. Now all I have to do is find my foci. And this works exactly the same way. I have to find c squared. So we know our formula for finding, we have to find c. So we know our formula for finding c squared is c squared equals a squared minus b squared. Okay, so a squared is 4, b squared is 1, so c squared equals 3. So c, oh, sorry about that, c is the square root of 3. Just centered here. C equals the square root of 3, which we know we need a decimal approximation of that to put it on our graph. So the square root of 3 is approximately 1.7. So remember, always going back to our center to graph our foci, Our center here is at 1, 1, so then I have to go up 1.7, and then I have to go down 1.7. Okay, so these are a little funny to write, the foci, but I think you'll grasp the concept pretty quickly. So I'm just going to go ahead and give myself a couple of parentheses for my foci. Okay, notice both of the foci have an x coordinate of 1 because they're in line with that center. So they both have an x coordinate of 1. They just have different y coordinates. I started out at 1 here on the y, and I went up square root of 3 to that foci. So the y coordinate of that point is simply 1 plus square root of 3. Remember, we don't want to give the decimal here. We like it in radical form. And then to get the other focus, I started here at 1 and went down square root of 3. So the coordinates of that is simply 1 minus square root of 3. And there are your foci. Okay? All right. So now, let's take a look at another one. Here's another equation for us to look at. If I take a look at this equation, I can immediately tell that this equation is the equation of a hyperbola. And the reason I can tell that is because of the minus in between. So just like I did with the ellipse, I have to graph the x's together, and I have to group the x's together and group the y's together. So I'm going to group the 4x squared with the minus 24x, and leave a blank, and then I'm going to group the y's together, and here's where it gets a little tricky. Negative y squared plus 6y and I'm going to subtract the 23 over to the other side. Okay, so on the x's I have to factor out that 4 because remember the x squared has to start with a 1. So that would be x squared minus 6x. And then on the y squared you actually have to factor out a negative 1, which is a little tricky. So it's y squared minus 6y equals negative 23. Okay, and now we're ready to complete the square with the x's and the y's. So on the x, I have to take half of the 6 and square it, so I have to add a 9. But now remember, since I factored out that 4, I didn't really add a 9. I really added a 9 times 4, which is a 36. So I have to add a 36 to my other side of my equation. And now I complete the square with the y's. Again, adding a 9. But you have to remember that that's not a 9, because if I were to think about redistributing that negative 1, that would be a negative 9. So I have to add a negative 9 to the other side of my equation. So what I'm left with is 4x minus 3 squared minus, you don't necessarily have to have that minus 1 there, y squared, I'm sorry, y minus 3 squared equals 4. And then once again, I have to divide everything by 4. So I have x minus 3 squared, and that cancels out that 4, but I can put it over 1, minus y minus 3 squared over 4 equals 1. Okay, so now I'm ready to pick out my center of my hyperbola. First of all, this is definitely going to be a horizontal hyperbola because the x comes first. So the center, remember to take the opposite of the h and the opposite of the k. So the center is 3, 3. And remember, in a hyperbola, the a comes first. So that's my a squared. And my b squared is 4. So in this case, a is 1 and b is 2. So we're going to go to our center of 3, 3 first of all, and put a dot at our center of 3, 3. I'm going to go out 1 on the x-axis, which just means I go out 1 to the right and 1 to the left. And I'm going to go out 2. So again, from that center, I'm going to go up 2 and down 2. And remember, on hyperbolas, we make a box. So I'm going to go ahead and make a box. And then draw in my asymptotes. And the asymptotes go corner to center to corner, corner of the box, through the center, corner of the box. And since this is a horizontal asymptote, it's going to open side to side. So my vertices become the side points. And my hyperbola looks something like this. And I follow the path of the asymptotes. Okay, now we need to find our foci. Again, it works very much the same as the one centered on the origin. In this case, remember that to find c, it's actually Pythagorean theorem. So c squared equals a squared plus b squared. Which would mean c squared would be 1 plus 4. So c squared would be 5. C would equal the square root of 5. And again, needing that decimal approximation, the square root of 5 is approximately 2.2. So we have to go 2.2 units either side of our center to find our foci. So remember now your center's at 3, 3. I'll highlight it again here. 3, 3. So I have to go 2.2 units inside that parabola, and 2.2 units inside the other parabola for our foci. And I'll label the foci. So now we just have to write the coordinates of those points. Notice both foci have the same y coordinate. They both have a y coordinate of 3. So I usually just fill that in first. They both have a y coordinate of 3. And then to find the x coordinate, if you notice, we started here at 3 and we went to the right square root of 5 units. So if we started at 3 and went to the right square root of 5 units, we added 3 plus square root of 5. And then to get the other focus, I started here at 3 and I went to the left square root of 3 units. So that's the same as 3, and then we went back square root of 5 units, so it's 3 minus square root of 5. And there's your foci. And your asymptotes, you have the formula for your asymptotes. They're pretty simple. It's y minus k, so it's y minus 3 equals plus or minus b over a. So our b is 2, our a is 1, so 2 over 1 I'm just going to leave as 2, x minus h, so it's x minus 3. And there you have your equations of your asymptotes. That looks like that 2 is an exponent, so I'm just going to fix it. It's 2 times the quantity, x minus 3. Okay, there you go. Thanks a lot, and I'll see you in class.